Okay guys, today we're going to talk about linear and quadratic parent functions. And there's basically two. Just like you have two parents, in algebra we only have two parent functions. Well, at least in algebra 1. You only have to worry about two. They are the linear parent function, which is given by y equals x, and the quadratic parent function, which is given by y equals x squared. The linear parent function looks like this. It goes through the origin. And the quadratic parent function looks a lot like this. It also goes through the origin. The main difference that you can notice is that in linear, you will see the word line. That means that if we're looking at a linear function, we're looking at a line. If you're looking at a quadratic parent function, or basically any function that's quadratic, you notice that there is the word u. And basically, anytime you're looking at a quadratic function, you're looking at something in the shape of a u. Some of the characteristics, well, the linear parent function passes through the origin, as we just said, passes through 0, 0. It also has a rate of change of 1. We'll talk more about that in a little bit. The quadratic parent function also passes through the origin 0, 0. Its vertex, which is the lowest point on it, is 0, 0. And the line of symmetry, if you notice from this graph, if we were to take a mirror and we were to put it right here on the y-axis, not the x-axis, but the y-axis, we could see that our parent function is symmetric across the y-axis. And to get this line, we would have to use the equation x equals 0. So the line of symmetry is x equals 0. It is on the y-axis. Its minimum value, it's also its vertex, it's also the origin. Its minimum value is 0, 0. The general form of the equation for the linear parent function is y equals mx plus b, or just y equals b. Some examples are y equals 3x plus 2. And the general form of the equation of a quadratic function is y equals ax squared plus bx plus c, or just y equals ax squared plus c. An example would be y equals 3x squared plus x plus any number that you want, plus 2. Some general graphs, anytime you're looking at a linear parent function, at a linear function, you're looking at something with a line. It does not necessarily have to go through the origin. And it may be going up, it may be going down. Anytime you're looking at a quadratic function, you're looking at something in the shape of a u. It may go up, it may go down, it may be on the side. The rate of change, which we talked about a little bit, is the change of y over the change in x. It is very easy to find, and it is the easiest way to tell whether a function is a quadratic or a linear, if you're just given points. So the change between 1 and 2 is 1. The change between -1 and 2 is 3. right? Because 1 plus 1 will give us 2, and negative 1 plus 3 will give us 2. So the rate of change right here would be the change in the y, which is 3, over the change in the x, which is 1. So 3 divided by 1 is 3. If this is a linear function, then our rate of change would be the exact same, regardless of what points we're looking at. So let's look at another 2 points. The change between 2 and 6 is 4. The change between 2 and 14 is 12. If we want to find the rate of change using those 2 points, we would do 12 divided by 4, which is equal to 3. And we can already see that our rate of change is the same. It is constant. So something that is important whenever you're looking at a linear function is that the rate of change is constant, meaning it is the same. And in this problem, we can see that's the case. If we're looking at a quadratic function, however, the rate of change is not constant. So for example, between 1 and 3, we have to add 2 to 1 to get to 3, and we have to add 8 to 3 to get to 11. If we find the rate of change there, the rate of change of the y is 8 over the rate of change of the x, which is 2. So that rate of change would be 4. The rate of change between 3 and 5, let me erase this to get some more space. Between 3 and 5 would be 2. And the rate of change between 11 and 35 would be 24. So if we want to find the rate of change, which is the change in y over the change in x, we would do 24 over 2, which is 12. And already we had said that the rate of change between the first 2 points is 4, because 8 divided by 2 is 4. Because 4 and 12 are not the same, that means our rate of change is not constant, it is not the same. We can say that this is not linear, this is quadratic. Okay, so these are your notes for quadratic and linear functions. Use these to complete your linear and quadratic assignment.